following video has been created for Mr. Beeler's AP Calculus class, which contains 11th and 12th graders. In this video, we will look at how the derivatives of certain functions can be found by using the quotient rule for derivatives. The content of this lesson aligns with the AP Calculus AB Learning Objective 2.1c, which states that students will be able to calculate derivatives. In previous lessons, you have learned how the power rule can be used to find the derivatives of polynomial, radical, and/or rational functions, and how the product rule can be used to find the derivative of a function that contains a product of two or more polynomial, radical, and/or rational expressions. In this lesson, we will learn how we can use the quotient rule to find the derivative of a rational function that contains a quotient of two polynomial, radical, and/or rational expressions. For example, look at the function below. F of x equals 5x to the fourth plus 3x squared divided by 4x cubed plus 2. The quotient rule states that the derivative of a quotient of two expressions u and v can be found as follows. If f of x equals u divided by v, then f prime of x equals v times u prime minus u times v prime divided by v squared. So let's look at how we can apply the quotient rule to our example function above. So if f of x equals 5x to the fourth plus 3x squared divided by 4x cubed plus 2, then we can say that u equals the numerator, which is 5x to the fourth plus 3x squared, and v equals the denominator, which is 4x cubed plus 2. By using the power rule, we can then determine that u prime is 20x cubed plus 6x, and v prime is 12x squared. Once again, the quotient rule states that if f of x equals u over v, then f prime of x equals v times u prime minus u times v prime over v squared. Thus, f prime of x, for our function f, equals the quantity 4x cubed plus 2 times the quantity 20x cubed plus 6x minus the quantity 5x to the fourth plus 3x squared times 12x squared divided by the quantity 4x cubed plus 2 squared. And upon simplifying the expression by multiplying the products and combining like terms, we get a final answer of f prime of x equals 5x to the sixth minus 3x to the fourth plus 10x cubed plus 3x divided by 4x to the sixth plus 4x cubed plus 1.